Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 2, Introduction, Part 2.
Managing. Leading a software development project usually stimulates several crucial questions, or should. Managers who are developing software systems as part of their jobs, SaaS founders building products for sale or subscription, and business owners creating software for the use of their business usually end up asking, why does it take so long? Why is it so expensive? Why are there so many errors? Why are costs and schedules so unpredictable? Why is quality so hard to achieve? We used to call this the software crisis, but for each of us SaaS founders, managers, or business owners, it's a personal crisis. It's gone on for so long that for institutions, government, and industry in general, it is really more of a chronic condition. Little can be done. The development of new hardware has outpaced our ability to build software. Moore's law states that the number of transistors in dense integrated circuits doubles about every 2 years. It has held up pretty well. Smaller is faster, so we have faster processors with more memory and storage at our disposal than ever. But having multiple cores or processors on a machine doesn't help a program run faster if it has not been developed to take advantage of them. Software is still pretty much handcrafted, and few people have the training and ability to work naturally on parallel processing. It's difficult enough to get one thread of control to work correctly. Introducing parallelism increases the complexity exponentially. Our demand for software has outpaced our ability to produce software. That is why many software developers of the 21 million worldwide have minimal or marginal skills. They can still be employed as developers because they have some knowledge and skills. That is also why a software project leader must recognize that the development team will need to be composed of average programmers rather than mythical super programmers. Cost and schedule estimates are often grossly inaccurate, by as much as an order of magnitude. A project my tech company recently completed rolled in at a whopping 400% overrun in effort. That is, the time and staffing required to complete the project were 4 times what had been originally estimated. Maintaining foreign code is always a crapshoot at best, and we crapped out. The original code was so badly written that it had to be substantially rewritten to have any chance of correcting it. Inaccurate estimates notwithstanding, the software systems produced are often of marginal quality. This leads to customer dissatisfaction and the unsurprising description of software as systems that almost work. A minimum viable product (MVP) approach to building new systems does nothing to reduce the expectation that most software sucks. Even though early adopters accept that they will be delivered software that only kinda works, users always expect more and better performance than they should expect. For some reason, users keep doing the same thing, running software in this case, and expecting different results that they will perform flawlessly. Finally, our ability to maintain programs is pretty bad. Part of that is because the code that's being maintained is pretty badly written to begin with. It is difficult to take badly written code and try fixing a defect or adding a new feature. Badly written code doesn't make sense, and finding a defect in amongst all the other errors that may be present becomes an exercise in futility. It's not unusual for a maintainer to need to rewrite badly written code in order to fix a defect that cannot be found in the original. Adding features is just as bad. Figuring out where to add code and how to make it work correctly within a nonsensical context is a primary cause of day drinking among developers. I made that up. Starting out behind. By the time our clients get to us, they are usually behind the power curve in their projects. Behind the power curve is an aviation expression, and it means that you're pushing full throttle and still descending because you have too much weight or too much drag, and even at full throttle, you don't have enough or any excess power to climb or stay level for that matter. Weight and drag in our analogy are technical debt and institutional inefficiency. Power is not only cash, but also the often unpaid effort, uncompensated overtime of leadership and managers trying to keep the project afloat in the face of seemingly insurmountable challenges. There's a limit to the amount of unpaid overtime that can be spent by even the most dedicated owner or manager. A SaaS product begins and relies on early adopters to buy the as yet unbuilt system on the promise of participating in a cool new thing. Oddly, this is the democratization of the smoke and mirrors sales presentations of software publishers in the days of yore pushing vaporware at conferences. Now vaporware is called a minimum viable product, and wireframe models attest to the fact that there is no there. At least not until enough early adopters cough up the filthy lucre to pay for the development. Pitches that begin with, imagine if you will, a system that may end up in the twilight zone. The business model popularized by the lean startup, that of creating a minimum viable product, ultimately culminates in crossing the chasm, moving from the early adopter customer base to technology followers, the hoi polloi. This new group of customers, a much larger group who will be responsible for the ultimate success or failure of the product, is guaranteed to be much less tolerant of defects, euphemistically called bugs, in the system. Not enjoying the privilege, so-called, of participating in the early stage development of the product, they expect a system that mostly works. Now, this is not to say that the lean startup model cannot work. It can. One of the tricky bits of the process, though, is to build the startup with the processes in place that ensure that the product produced will be maintainable. Rewriting or re-architecting the application and then rewriting it is guaranteed to be an expensive process. People want to believe that there's a path leading their product idea into the stratospheric spaces occupied by Basecamp, Facebook, or Twitter, and $1 billion exit. A non-technical SaaS founder may have the system developed, and they may even be able to sell it to an early adopter population. But if they aren't savvy about building the system, then they may end up trying to cross the chasm behind the power curve, which is only good for a one-way trip into the abyss. But it isn't just SaaS founders who are counting on the turn of a friendly card. A manager without a technical background who has been put in charge of a unit that includes the oversight of a software project is often in the same boat. They need to find a way to manage a process, the details of which are foreign to them. Business owners who need or want an app or a software tool that gives them a competitive advantage or a modern look to appeal to their new customer segment are also setting sail into the unknown, over distant horizons, where there be the invisible dragons of complexity, conformity, and changeability. This book is intended to help these people succeed, or at least to help them fail to fail.
That ends the introduction. Join us next time for Episode 3, Part 1 of Chapter 1, Software Introduction. That's it for me for you for now. Be careful out there. Bye.